there guys, it's Mr. Herbst here, and today our focus is going to be on the skeletal system. Now, there are many functions to the skeletal system, but the one that probably most people think of at first is support. It supports our body. It also protects internal organs, and it also provides movement, allows us to move around, and also it is a place for storage of mineral reserves. And one of those minerals particularly is calcium. Our muscles, including our heart, would not work if we did not have calcium in our blood. When our blood runs low on calcium, what do we turn to first as a new place to get calcium? That's right. We turn to our bones as a place to get more calcium into our blood. It's also a place for blood cell formation. Our blood cells are formed in our bones. Now, how many bones do we have? There are 206 bones in the entire human body. In this unit, we are going to memorize all 206. Just kidding. We're not going to memorize that many. But it's actually pretty crazy. Kind of, if you look over here at a foot, look at how many bones are just in the foot alone. That's a lot of bones. There are 206 total bones in the adult human skeleton. Now, there are two types or two divisions to the human skeleton. One of those divisions is called the axial skeleton. That includes the skull, the vertebral column, and the rib cage. The axial skeleton is everything kind of sort of in the middle of your body. So it includes the skull, the rib cage, and the spine. The appendicular skeleton, use your root words here. Once again, I always say the best way to learn science is to learn the root words. Think append or appendage. If you know what an appendage is, this word might help you be able to figure out the appendicular skeleton. An appendage is your arms and your legs. The appendicular skeleton is your arms and legs. Includes the pelvis and the shoulder areas as well. Moving on, the structure of a bone. We're not going to go very deep into the structure of a bone, but just know that bone is actually living tissue. It's composed of many different kinds of cells, primarily called osteocytes. They build up or tear down bone, and bones are composed of networks of cells and protein fibers. This thing right here, right there in the middle, that is a bone cell, and it deposits lots of calcium on the outside of the cell, which ultimately allows for that bone to, well, be a bone. There are 5 major parts to the bone. The first part is called the periosteum. That is the outer covering of the bone. That is just, the outer surface. The next part is the compact bone or the dense bone tissue. That is the underneath of the periosteum. That is the bone right here. Primarily when you think of bone, you're probably thinking of the compact bone. But inside of the compact bone is spongy bone. And you may be wondering, why do we want sort of porous bone to be in there? Well, if you think about it, if you look at a periodic table of elements in chemistry, calcium is actually a metal, and metals are heavy. If our entire bones were made out of compact bones, our bones would be really, really heavy. So our bones, through the course of millions of years of evolution, have evolved to have sponginess or porous areas that are still very strong, but they don't really add any extra weight. We also have the bone marrow, which is on the inside of our bones. We have 2 types of bone marrow. We have the red kind and the yellow kind. The red kind produces blood cells, and the yellow kind is primarily made up of fat. So the bone marrow is on the inside. I'll show you a picture in a second what that looks like. And then we also have the Haversian canals. Those are areas in between, inside the bone, that allow for blood vessels and nerves to run through our bones. Here's a picture of all those things I just kind of ran through. One of those things is the bone marrow. That is right here in the center of the bone. That is the place where new blood is formed. It also is a place where we're going to have yellow bone marrow, which is primarily just composed of fat. Here we have that spongy bone. But as I was saying, it's made up of very porous areas. It's still very strong, but it doesn't add too much weight. Then here is our solid bone. Another name for solid bone is the compact bone. Once again, that is where we have the really, really thick areas of our bone, primarily made of very dense calcium. The outer membrane is the periosteum. Also, a ligament is present in most bones, which connect bone to bone. We also have an area where we have cartilage. We'll talk about that in a second. A cartilage area is a connection is where we connect bone to bone, but it allows for those bones to move freely against each other without actually having to rub and sort of scratch against each other. Ossification, I'm gonna talk about this for a second. Ossification is the process where cartilage is replaced by bone. So it is the process or the formation of new bones. So when you were an embryo, when all of us started out as a very, very small organism called an embryo, at that time we were composed, all of our skeleton was composed of pretty much just cartilage. But over time, our cartilage got replaced by bone, and now, as an adult or a near adult, most of your bones have been replaced by cartilage. There might still be some cartilage left over, which was probably just only at the ends of your bones, which allows for a cushion between the bones so the bones don't rub up against each other. And so once all of the bones have become ossified, they stop growing. And that usually happens for males around age 20 to 25, and for females around age 18 to 22. Next focus is going to be on bone joints. There are actually several bone joints in your body. Joints are an area that allow bone to attach to another bone. So over here you can see that this area here is a bone joint right there in the middle, but there's actually a lot more to a bone joint than we actually think about. There are areas like the bursa area right here, which is a little fluid-filled sac that allows it cushions the area between the joints. You may have heard of this disease before called bursitis. Bursitis is when that area right there gets inflamed and people's joints get really, really painful. So the first type of joint we're going to talk about here is called our immovable joints. That is where bones are fused together by connective tissue. And a really good example of that is the bones in the skull. Right in here where you see all this squiggly stuff, that is actually made of different kinds of bones. Right here is our parietal bones, and then also our occipital bones right here in the back of our skull. Those are connected together by fused or immovable bones. The next joints are the slightly movable joints. This is where we get some movement. It's the space between some joints, and a really good example of that is our spinal column or our vertebral column. Right in here, between two vertebrae, is some cartilage. Slightly movable joints are also called cartilaginous joints. They allow for some movement, but not very a big full range of motion. Then also we have our freely movable joints, which permit a lot of movement in either one or more directions. And we have four types that we're going to go ahead and talk about. We have the ball and socket type of freely movable joint. We have the hinge, pivot, and saddle joints. First type is the ball and socket. This is, once again, this is a freely movable joint. This right here is between your femur bone and your pelvis. You can see why it's called a ball and socket, because right here, the top of the femur right here, the head of the femur looks like a ball, and then the part of the hip there actually looks like a socket. And so that allows for a very large range of motion. Also, another ball and socket is between our scapula or our shoulder blade and our arm. That allows for a very, very large range of motion. The next type of freely movable joint is the hinge bone. A really good example of that is right here at your elbow. The thing about hinges is they allow motion only in one direction. If you think about it like this, take a look at your arm. It really only can move in one direction. You can't really move it, the other way. It's possible to hyperextend your arm, but that's really painful and could cause some serious injury. The next type of joint is the pivotal joint that is primarily rotational. And that occurs in a couple places in our body, but one of the most famous places is between the first and second vertebra in our spine. The first one is called our atlas bone or atlas vertebra, and the next one is called the axis. When you think of atlas, think, atlases hold up the world. So guess what? What do you think the atlas bone does? It holds up your head. And the axis bone, twisting on an axis. Those two bones right there, those first and second vertebra, allow our neck to twist left and right. We have a pretty large range of rotational motion. Another pivotal joint that we have in our body is here in our forearm, which allows our forearm to twist this way. And then lastly, the last joint we're going to concentrate on is called the saddle joint, and that is where sort of we have two convex and concave joints put together, and that is found primarily in our thumbs. Now, if you look at our thumbs, with your thumb you can move it up and down, but you can also move it left to right. It's not necessarily rotational, because if you actually try to feel out your thumb, it has these points in it where it's actually kind of hard to move it. Well, that's because it's not actually a ball and socket joint. It's actually called a saddle joint, which really allows for up and down motions and left to right movements. But you can do a rotational movement with your thumb, but it's not as easy and it feels kind of awkward. Anyway, here, guys, I highly recommend writing down. I know I spoke a little bit more than what the notes were saying. I highly recommend writing down all of those things that I wrote down on screen. Make sure you do complete the Google form below. Anyway, this is Mr. Herbst, and I'm signing off, folks. Y'all have a nice day.